Welcome to Nitiz Sharma Global Tech, and I'm Kuldeep, your trainer for this session today. All right, so what we are going to cover in this one, we are going to touch a bit of BGP and MPLS both, right? So BGP and MPLS, as if you are aware of, like they are two very important protocols from the ISP and SP, Internet Service Provider and Service Provider level networks, right? So we are going to dive into some of the concepts about BGP and MPLS. Okay, so what we are going to like cover in this session. So see here. So what we have here, if I can adjust this a bit. Okay, so I have like, okay, first of all, let's skip it for now. So say we have some provider network. All right, let's say we have some provider network here. Okay, so there are these ISPs and there are these SPs, Internet Service Provider Networks and Service Provider Networks. So what basically your service provider networks does, na? So let's say you have a site here. Okay, so there is some organization A, and they have a site one in, I don't know, let's say Bangalore, and this organization A, right, same organization, they have this site two somewhere around the globe, or maybe let's say in India, in Delhi, right? So your Delhi office, you want to connect with your headquarter, maybe let's say in Bangalore, and you are taking these services, right, the service provider lines. So what they are doing for you, they are interconnecting your multiple offices. So basically that's the function of a service provider network. Okay, how this BGP and MPLS comes into picture there. Okay, so we are going to talk a little bit about that. So what I have here, I'll be having this service provider network. So the simulation will be like this. So I'll have some service provider networks like this. So those will be router 1, router 2, router 3, and the service provider AS. I'm going to assume, let's say this will be AS 200, right? And what is AS? So in BGP, we know that whenever you are trying to identify your organization or your company or whatever you call that, your network, your autonomous system, you need a number, right? So INA gives you like IP and MAC and port addresses. So they have ASN also. So this is the concept of AS. So we discussed this concept first in EIGRP in our earlier studies, and then we also talk about ASN in the BGP studies. So ASN is the required parameter when you are trying to configure BGP. So without this AS number, you can't run BGP, and only on just one ASN you can run BGP. You can have multiple OSPF processes on your routers. You can have multiple EIGRP processes on your router, but you cannot have multiple processes of AS or let's say BGP. So we'll talk about these. I'll show you all of these in real action. But yeah, for now, the AS for provider, we are assuming it will be 200, and say for the customer, right? So we are saying this is AS 100, right? So everybody need AS numbers if you are trying to plan the BGP implementation and all. So yeah, the same AS I'm having because these are the two sides of a same organization. Okay. Right, then let's say we'll be having some IP connectivity here, I'll show you, and then we'll be having the same like layer 3 IP connectivity here, and on top of that, what we'll have, है ना? I'll say that I have some roots here, some prefixes here. Let's say I'll create one loop back 0 with let's say 1.1.0/24, and I have let's say one loop back here, same let's say, and this will be okay. The router simulation here will be router 4, and here I'll assume the router is router 5, right? So as per the router name, I'm having the loop back addresses. You can have your own addresses for that matter, right? So what I'll do first in BGP, right? So in service providers and in large implementations of networks, we know we need BGP. So when do you need BGP, right? So that is one discussion topic. So in our BGP, introductory sessions, we talk about that, and yeah, when your AS is a transit, when you need to put policies on your incoming and outgoing traffic and all, so you need BGP with your service provider and all. And yeah, in internet service providers, internet networks, you also need BGP from ISP to ISP and all. But for now, let's focus on the BGP connection or BGP neighbors with what we call by the name of peers, right? So this is one peering we have here. So this peering of BGP is of two types, right? One is we know IBGP, and one is famously implemented as EBGP, which was previously EGP, but now we have that external and internal BGP variants. So in the inter AS BGP session, we have the EBGP. So this will be our EBGP neighborship, and we'll have what? Indirect neighborship. We'll focus on some real-time scenario. So here the neighborship I can make or perform based on these directly connected reachable addresses, right? But let's try to be real here, and I'll say that okay, we don't have direct neighborship because we may be having multiple links from customer to the provider for load balancing maybe, or for fault tolerance maybe. So yeah, what I'll do, I'll create, let's say, loopback 0 here also, and that will be okay. This is 4 now, so I'll say this is 4.4.0 for router 1. This will be 1.1.0, and the BGP neighborship between R1 and R3 will be again indirect loop 0, but this BGP will be what? Your IBGP, internal BGP, because then you'll be performing the BGP neighborship in between two routers of the same AS. So these are the two routers R1 and R3, they belong to the same AS, so it makes the BGP peering as internal BGP. Whereas router 1 and router 4, also router 3 and router 5, they belong to different AS. Router 3 to 200, router 5 200. So that makes this BGP peering as EBGP peering, right? Okay, so again from R4 to R1, we are going to try to cover the indirect neighborship. Again from R1 to R3, indirect neighborship. From R3 to R5, indirect neighborship. And everywhere we have the loopback address is configured. All right, now you'll be wondering about what about R2? We don't have any BGP peering between R1 and R2 and R2 and R3. Okay, what about that? So when we discuss MPLS now, there is this feature characteristic or the advantage of MPLS, you can say that MPLS makes our service provider core BGP free. Let's say there are plenty of routers in here, because there are not just 2 or 3 routers in your BGP core, right? Sorry, your service provider core. So there are routers like this, maybe I'm just assuming some connections. So you don't need to run BGP everywhere inside your service provider network. One more thing, if you talk about terminology perspective, these routers na, the service provider routers which are connected directly to the customer routers, they are known as PE, provider edge routers, and customer routers directly connected to ISP or PE are known as customer edge routers. Same here, this is your provider edge router, this is your customer edge router, and these internal core routers of provider are your P or simply provider routers. Let's say if you have some customer router here also, that will be only customer router, right? Some other router than connected directly to the ISP. So those will be just not provider, actually customer routers. So what we do have between the PE and CE, we have EBGP neighborship. All right, between PE to PE, and maybe someday if you need PE to P or P to P BGP neighborship, that will be IBGP. For example, here from PE to PE, right, R1 to R3, I have this IBGP neighborship. But again, the point is why I don't need IBGP on different internal provider routers. For example, in R2 here, because as I told you, MPLS makes our provider core BGP free. That is one bigger biggest advantage we have. How it saves your resources of your internal routers. So that is, I guess, the biggest advantage. One thing is this. And what about MPLS? MPLS have its own, feature set. It makes your processing faster, CPU, RAM utilization better, and it gives you quality of service. Any transport, you can carry on the MPLS and so on and on. So MPLS has huge number of benefits, which was the reason it was heavily adopted in the industry from last so many, decades. All right. So, okay, coming to this. So this is so exciting. That how this actually is implemented and how things are actually working in the background and all. So yeah, let's see that in the real picture here. So let me just change the color maybe a bit. Black it is. So yeah, R4 I have. So this is like AS100, right? Same AS100, and this is the service provider here, right? And there I have just three routers. I have this PE to CE connection, this PE to CE BGP, EBGP connection I'll have. Then I'll perform the IBGP and MPLS. So okay, let me brief you how we are going to proceed with the lab, right? So this was about the theoretical part. So what about the lab part? I will say, okay, we have this let's say interface 1.1.0/24, this prefix in, okay, maybe 4.4.0, right, on R4. I have this 5.5.0/24 prefix on other side. So maybe let's say here is this internal network. So some of my users, let's say 4.4.4.19, and here I have some DMZ and servers and all. Let's say this is 25, and these clients, right, want to access these servers. So first site want to access the second site, and what they are using, the service provider networks services for that. Okay, so I told you for that what you do you need first the BGP connection, right? So that's what we are going to focus first of all about BGP neighborship. Is my pen lacking or what? So first the BGP connection, right? So here the EBGP, and here the also EBG BGP connection, and here we will have the IBGP connection. Okay, first thing. So we'll do both. Then I'll show you, okay, about BGP, what the indirect neighborship. Okay, so from R1 to R4 I'll have neighborship between loop back. So here also I'll create loopback 1.1.0, and here I'll create, I don't think here I need the loop back, right? So again here I'll say 3.3.0. So in here I'll say the neighborship will be between these two loopbacks. So what we will need there in indirect neighborship, right? So we'll talk about EBGP multi-hop concept there, right? And what else we'll talk about? Okay, same here and same here. We'll talk about EBGP multi-hop concept. Then what about IBGP, right? So we'll talk about the IBGP connection, again indirect. And here what we need? We need one concept is update source. So this will be needing in the EBGP also and in the IBGP also. So what is the second concept? That is, let me say this is first one in BGP, and then we have the update source concept, right? What else? Still you'll see that, okay, by using these two commands the EBGP neighborship will be done between PE to CE, but still the IBGP neighborship will not be done in the provider core, let's say from R1 to R3. So why is that, right? Or let's say your routes will not be exchanged. Why is that? So we'll talk about the third concept, which is next hop cell. So we'll talk about a little bit about the loop prevention mechanism of both EBGP and the IBGP maybe, right? So let's see what it will allow us the session from the lab perspective, but yeah, I'll try to cover like many things in here. Still, after everything is done, right? Your neighborship is done. But what will happen? So your IBGP neighborship will be there, your EBGP neighborship will be there. I'll show you. And still, when you will, I'll also show you how to advertise the, prefixes in BGP process. So when you will, in BGP on R4, you will advertise this prefix. So how it will be propagated from your end or customer end to the provider end. Okay, so from here to here. Okay, so why this IBGP full mesh neighborship is needed, or let's say why IGP, or let's say OSPF and ISIS is also needed with BGP. So that concept we will talk about. So you can see it's a lot that happens, from configuration wise, from understanding wise, and from the implementation wise. So there are a lot of things that we need to take care of and that we need to be aware of, because a lot can go wrong and we need to be like very aware when we are doing these configurations and implementations in the production network. So we'll discuss everything, and lastly I'll show you after everything is done, still your R1 will not be able to traverse your route to R3 or in your provider core, because R2 have no idea about BGP neighborship. Then how your routes will be propagated from here to there. So for that we'll talk about the role of MPLS in your provider core. So I hope that's it from this perspective, this point of view, and let's now head to the lab part. So this is the exact topology that we have been talking about. And now I have configured the IP addresses, and rest of the part we'll do it together, right? Let me show you. So these are the addresses configured on R1, so which is ISP PE router, right? So I have given this host name as conveniently as possible, so try to make sense of it. So ISP 200 means the 200 is AS number used in the ISP network. PE, this is the PE router, and for site 1, right? So similarly, if you'll check on R3, show IP interface brief, and if you'll check the name, so this is ISP 200, same PE router, but for site 2. That was for site 1, right? Again, what about R2? Show IP interface brief. So R2 is what? ISP 200 P router, right? Provider. And what about R4 and R5? Because understanding and creating topologies are as important as performing and executing and running your commands, right? Remember that. CE100, so this is my customer edge in 100 AS, and this is for site 1. So this is router for the site 1 router. Show IP interface brief. The addresses seems good, physical and loopback. And finally, if you'll see, for site 2 we have the required addressing, right? 35 and 5. Okay, now if I try to check about the, let's say, BGP, so section BGP, you will find nothing because I haven't configured anything else. So what we'll do, first I'll try to configure the EBGP neighborship between R1 and R4, right? So I'll start from, let's say, R1 or maybe R4. So router BGP, and the process for ISP is 200. Router BGP. Okay, I need to go to the global mode. Router BGP 200, right? So we are in the global configuration mode and under the BGP protocol configuration. So here I need to provide the neighbor. So who is my neighbor? And remember, I'm not doing this direct neighborship. I'm doing indirect neighborship using the loopback addresses. So that is in remote AS of 100. So my customers are in AS 100 and I am in AS 200. So it makes this BGP peering as EBGP peering, where the local AS and the remote AS are different, right? Okay, what else we need? So first let's do it, one by one. So I have just configured this one command, neighbor command, right? And again, if I go to the global mode for the site router, site 1 router BGP, here the process is 100. So I told you, if you try to run another BGP process, you cannot do that because already it is running with 100 and only one process can be run on your router for BGP. Whereas in OSPF or other routing protocols, let's say you can do one and you can also say two, right? So that's not a problem for OSPF, EIGRP and all. So I'm removing them again, router BGP 100, and here my neighbor will be who? R1. So for R1 I have the loopback 1.1.1.1, right? /24 by the way. And in which AS is R1, that will be in 200. So now again this makes the just neighborship command complete between R4 and R1. But do we have the neighborship? Let's see. Do show IP BGP summary. So the state is idle, right? Okay, so what happens in the background now, that your TCP three-way handshake is happening in the background, because BGP is not actually a routing protocol, but you can say an application or TCP port number 179, or you can say it is a policy protocol, and you use it when you need to what you can say, manipulate your inbound or outbound traffic across multiple different routing domains. So for that we also say that this BGP is reliable. It must be reliable, right? Implemented on that scale and for that accuracy and all. So TCP makes sure all of your BGP packets are acknowledged. So before anything can happen in BGP, you need that three-way handshake like any other TCP based protocol, right? So do show TCP brief. So there is nothing, right? So we should have some output here, show TCP brief, right? But why don't we have that? For that, your reachability should be there. Let's say if I was making the BGP connection from R1 to R4 via what? 14.1.1.1 and 14.1.1.4. So from R1, if you ping 14.1.1.4 R4, it's not D actually, it's do, right? So you can see it is reaching to that IP again. R4 also, if you try to ping, you're directly connected, right? Interface, so that will be 14.1.1. So that is reachable. So on that, if you were configuring direct BGP neighborship, your TCP three-way handshake would be there and not a problem. But in here, the reachability is not there. So before you try to have the BGP neighborship, remember you need the connectivity, the reachability. Okay, so when you will talk about the BGP best path selection parameters and all, attributes, BGP attributes. So there are these 12 attributes, and first of them is NHR, next hop reachability. So before that or without that, you don't have anything in BGP, right? No neighborship, no connectivity, no transport, nothing. So what I will do, so your router's loopbacks can reach each other. See, if you try to ping on ISP 200, so I'm on R1, है ना? So if I try to ping 4.4.4, है ना, loopback of my R4 or customer site 1 from source of 1.1.1, because these are two loopback addresses, I'm trying to make the EBGP neighborship forming. So they are not reaching to each other. What should I do? We can have static routes. So let's do that. So from ISP or SP to customer, I am doing this, let's say static route, right? 1.1, not 1 actually, 4.4.0, and it's a mask, which is not default, but /24, and I'm saying okay, it is exiting out of 0 by 0. All right. What about R4? I need to reach to R1 from R4 also. So that will be, so I'm putting this default route from customer to the provider, and that will again exit out of 0 by 0. Now do I have the connectivity? Now let's try do ping 1.1 from customer, and the source will be loopback 0. So hopefully it should be there if we have the route. So do show IP route. If you check, we have a static route here, static default at the customer side and a static route on the provider side, right? Okay, so we have the reachability. Again, we can check from this side also. You can do that. And okay, I'm exiting out of here. Now what else? What do we have? Do show IP BGP summary. So again, we have this idle state. Okay, do show TCP brief. Okay, nothing. So what else we are missing here? So you need to remember one more important concept about the BGP neighborship, and that is the multi-hop concept. When you are using EBGP, right, exterior BGP, so the TTL value you are using na, that is by default 1. So if it was direct neighborship between R1 and R4, so your packet will be leaving R4, TTL 1, reaching to R1, okay, and it need not process it to forward further because this was the direct packet, and R1 will be receiving that, and that was not a problem. So neighborship would be there. But when it is indirect neighborship, your packets are going, let's say, from R4 to R1 and then from R1 to loopback. So it makes the hop 2, but you are having 1. So what are the solution? Either you can disable this directly connected check by a command which is there in the BGP implementation, or you can use this EBGP multi-hop and you can provide the desired number of hop, because if you do default, then it creates a security flaw in your BGP implementation, because by default it picks higher value. So what we can do? So I go to router BGP 200 and my neighbor is 4.4.4. Okay, and here I can say, not this one, EBGP multi-hop, and how many hops I need? Just 2. You can just press enter on neighbor 4.4.4.4 EBGP multi-hop without specifying 2, but it makes it more secure because this is your implementation, this is your planned network and topology. The hop situations and distance of your devices and prefixes. Same about what on R4, then router BGP 100, and what else, neighbor will be 1.1.1 and EBGP multi-hop. You can see here the default value could be 255. Now let's wait and see if we have the neighborship. So you can wait and wait and wait, but still it will be idle. Now what next? So we have talked about what? First, the indirect neighborship using loopback. First, they were not reachable. We made them reachable. Next, we have changed the default behavior of EBGP neighborship from default TTL value of 1 to 2. That makes sense. What else now? The third thing, right? So remember, whenever your BGP routers are sending the packets and updates, when you talk about BGP messages, so there are these open messages, keep alive and updates, route refreshes and all. So they are sent by this physical gig 0 by 0 exit interface towards another BGP peers. Now what you are doing, you are making the neighborship from your loopback interfaces. So you don't want this directly connected neighborship, but the loopback based neighborship, right? So in short, if I don't explain all the nitty-gritty details in the background, so I can just say, okay, your neighbor for site 1, it is 1.1.1. so the update source should not be the default physical, no, but the loopback address. Who is your loopback which you are making neighborship with? That is 0, loopback 0. That's it. So that is one more command that you need on your EBGP neighbors actually. Okay, so here 4.4.4, and what we were doing, that update source loopback 0. So now if everything is okay, if we are not missing anything else, and if we give BGP enough time, because it is on purpose a slow protocol from this perspective, because it is obviously routing on this internet scale, it should be not like every time somebody is sending message and it is accepting them, making changes in the table, making bringing instability to the BGP table and all, a whole internet routing table. So no, you just accept whatever is must be accepted and all right. So that makes your BGP neighborship up. So here you should be able to see the output, the three-way handshake. So where you can see one side device, the initiator will be using some random port number, and the other side will be using that standard TCP port number 179. Now you can see for where you are on the R1 and ISP side. So that is your neighbor address, and with that you have the port address. So that is one socket, and on this side the address is your local, and with your local TCP randomly generated port number. So when the neighbor will reply so that address will be like this in the local part, and in the foreign part it will be like this. So this will be changed, and the state is established, and now it will be changed from idle to what, some zero number or something, because we are not changing any prefixes, exchanging any prefixes and all. So here you can say table one. Okay, let me show you that. Do show IPBGP summary, but before that let me show you on R4 the TCP status. R4 membership is up. Do show TCP brief. It will take some time, I guess. Let's check that BGP neighborship. Here you can see state prefixes received are 0, because these two routers are not exchanging anything. The time here, so this parameter is sometimes is used for the best path selection. Again, the oldest route, there are no congestions and nothing hold in the buffers. The version 1, so whenever your tables are updated, or let's say whenever update messages are exchanged, so then your table version, this changes. So it shows you, I guess, the recentness of your BGP processes or changes or tables, right? So how many messages, so they will keep changing, increasing and all. It will be same always for your AS. This is BGP version 4 we are using right now. So this is BGP version, and this is BGP table version. So it will be increasing, but this will be 4. And who is your neighbor? For. So when we'll do more and more BGP neighborship, so we will have different neighbors. So first we have just one, and when I'll make R3 the neighbor of our R1 also, we'll have like same kind of output for that R3 neighbor also with the 3.3.3. Okay, on R4 you can see that is in your local and that is in your foreign, as we have discussed, and the state is established. Again, if you'll say do show IPBGP summary, which shows you the BGP status of your neighborship, and that's okay. Everything looks good from R1 to R4. What about R3 to R5? So we can do it quickly this time, I guess, because we know what we need to do for now. So router BGP 200 for service provider. Neighbor will be my 5.5.5, and it is in the remote AS of 100. So what I need to do again, I need to change the update source, and that will be my loopback 0. And what else I need to change? I need to change the EBGP multi-hop to 2, from 1 to 2. So from R3 to R5 and R5 to R1 also. So router BGP 100 neighbor will be your 3.3.3 and your remote AS will be 200. Okay, and then you need to update your source, that will be loop 0, and the EBGP multi-hop. But still, there will be no neighborship and all. Why? Because you don't have any reachability, right, between your loopback interfaces. So if you'll check your TCP connection, there will be nothing, and without TCP connection there will be nothing later on. First you need the three-way handshake. So let's do what on your customer provide this default route, right, towards the service provider using your gig 0 by 0 as the exit interface. Similarly on R3 you can say, okay, to reach your loopback I'm using this command right here. So let's wait for some time, and when the timer values are okay, then your BGP messages will be exchanged and will be having the neighborship like that. Okay, do show TCP brief, you'll be having the output here, and meanwhile do show IP BGP summary, you can see here. Still we are not exchanging any prefixes at all, so it is 0 there. So the neighbor is only 1, 3, and in here you can check the same thing, and any default source port on the initiator side, and on the remote side the standard BGP port. Okay, then so that makes the EBGP neighborship part done from our side, right? So what else? From R1 to R3 we need the IBGP neighborship, but the first thing is we need reachability between the loopback interfaces. So in that EBGP part we have done the static route, okay, because you have one or two routes from your provider to the customer, right? But in your provider network, service provider network, you have whole bunch of routers, right, whole bunch of prefixes and all. So imagine configuring static routing in that, right? So that's why we don't prefer that. You don't use static, you can't use default because there will be no neighborship. If you configure default routing and all, even between two devices, two routers in provider, there will be no neighborship. So that's for a different class maybe, but for now I'm configuring that EIGRP IGP for scalability purpose in the provider network. You can configure OSPF, you can configure ISIS, whatever your choice is. Now router EIGRP, let's match the AS number maybe, or you could use a different one also. Now what will I do? So first auto summary, then network will be what, first my loopback address, let me exchange it in BGP process, and then I have my 12.1.0 in the picture. All right, so R2 again, so I need the IGP configuration on all the provider routers. So router EIGRP, the same AS, auto summary, and network. I'm advertising everything on R2. So there should be some neighborship message. It is there. Router EIGRP 200, and here not everything but just the required addresses in IGP or EIGRP process. What else is there? 23. All right, so we should be having neighborship coming up, right? So we should be having the reachability also. All right, do ping 3.3.3, so it is there, And now we can configure the IBGP neighborship from R1 to R3 indirect neighborship using the loopback addresses. We could have configured, directly from the physical interfaces, right? But we prefer the loopback side. Okay, router BGP 200, the neighbor will be your 3.3.3 on R1, and it will be in the remote as same. So this same number here in the BGP process, and in the neighbor command it makes this BGP implementation as IBGP. Okay, so what else we need? Neighbor 3.3.3. So remember that EBGP multi-hop command, it's not needed here because there the TTL value was 1. Here in IBGP the TTL value is 255. So you don't need to worry about that. What else? Update source. Yeah, you need to worry about that because whenever you are making the neighborship possible by the loopbacks, you need to change your default originating interface from that physical to the one that you are making the neighborship with, which is loopbacks in our case. That makes it update source loopback, whatever you loopback you are using for neighborship. So for my case it is loopback 0 1.1.1.1 for R1. What else is needed here? So one more important concept, but before going to that, let me configure BGP on the other end also. So the neighbor will be 1.1.1 for R3, same AS. Okay, and update source loopback 0. But if you'll keep waiting and waiting, there will be what, up neighborship. Okay, fantastic. So that makes us eligible to move to the next part. So let me show you this first. To show IP BGP. Okay, that was something I was trying to bring it up, but let's focus on first thing first. Yeah, so you can see here there are two neighbors, right? One is your IBGP, one is your EBGP, but still you are not receiving anything, and because you are not receiving anything, it means there is nothing to show in the BGP table. Remember, there are two tables. Routers routing table, do show IP route. So where you have the connected routes, your local IPs, and your IGP routes, which are represented by the D's here. The EIGRP routes showing your AD, your metric, next hops, your connected interfaces, your the time your route is present there, things like that. So that's why the reachability was possible. But because you are not sharing anything in the BGP process, so if you'll check do show run, and if you'll check okay section BGP, so it is passing through that whole output, so taking time. Now you can see here I have just brought up the neighborship part, but I have not exchanged anything. So what I have the objective that I want to reach from R4's clients to R5 servers. So for that I need to advertise those, right? So I have this routing table, and from that routing table I want to put some routes in the BGP table. And remember, only the routes which are in your routing table can be put in your BGP table, and with the exact mask. So there are some things that we can discuss, but I guess that will make this video 3-4 hours if we keep continue discussing every little thing. But yeah, let me show you by doing here, so if you want to advertise, let's say the fours. Okay, let it let's get it in this way. If your R4's clients, which are in let's say 4.4.0 subnet, they want to reach your R5's server, which are in the 5.5.5.0 subnet. So what you need to do, you need to exchange 4's subnet in BGP process on R4 so that it can reach R1, it can pass through R3, and finally it can be exchanged with R5. And vice versa, on R5 you need to advertise your 5.5.5.0 prefix in BGP so that it could be exchanged with R3 in EBGP, and it could be exchanged with R1 in IBGP and ultimately with the R4 in EBGP, so that each router in each BGP process has the information about the remote prefix. So that is the only way to be reachable, right? So that's what we are trying to do here. So I'm advertising this, and you need to use this exact 24 mask. If you will use something different, it will not be put into the BGP table. You can try that. So I'm using the exact mask. Now if you'll check do show IP BGP, so this is your directly advertised route or self advertised injected route, you can say. Next hop is 0. Next hop represent what? That it is your own network, on subnet, that you have configured this interface on your router itself, right? So it shows that when you'll talk about, that is a different discussion topic, but just for bringing it up, that okay, it shows you that it is your own route, that it is your own physical interface configured IP, or maybe on the loopback configured. Now what is this? It is your best route, star greater than, so it shows that it is valid plus best path, so it will be exchanged with the neighbor. Remember, there can be multiple bunch of routes in your BGP table, but not necessarily all of them will be exchanged with the neighbor BGP peer. Why? Because only the best routes are exchanged, right? From your BGP table, only the best routes are exchanged with the neighbors. So let's see if with R1 have we exchanged anything. So the command to see the BGP table is do show IP BGP. Command to see the neighborship is do show IP BGP summary. And if you'll see here now, if you have a number here, only then you can see the output in this one. Now you can see this is showing me R. Okay, why? So again, this is one more thing. So we can discuss. I guess there will be thing coming up and up, and we can discuss again and again. But yeah, what is this R? Rib failure. If you'll check, do show IP route. So if you remember, I have configured this static route on R1 towards R4 for this 4.4.0. See. So what is happening? BGP AD value, EBGP AD value is 20, but the static route AD value is what? 1. And from your routing basics, you should be aware that lower AD value is first preferred, then the router check other things in the route table lookup. So that's why it is there, but it is not saying that okay, it is not the best path. In here it is saying it is best path, but not present in the routing table. In BGP table, it is present as the best path, but not present as the best path in the routing table, because it is present in the routing table with some lower AD value, what you can say, way or protocol or routing mechanism. So that is about the rib failure thing here. What else? Is it exchanged with R3? Let me see. Do show IP BGP summary. So can you see prefix received? Yes. From what? R1. Now you can see that okay, what is there? So this is present there. Now interestingly, what is happening here? If you'll check do show IP route, do show IP route, and 1 2 3 are there, 5 is there, okay, statically configured, 12 from your EIGRP, so everything you have. But what about this one? Why it is not the best? Remember, it is in the BGP table, but it has not been put into the routing table, because you don't have that greater than symbol, which makes it okay, this is the best path also. So being present in the BGP table doesn't make it the best path, and if it is not the best path, it will not be shared with the neighbor routers, neighbor BGP peers. Remember the thing we have discussed earlier. Now why it is not the best? Because remember, from your R3, and if you see here, okay, let me show you this one. What is the next hop here? 4.4.4. So for here R1, see, on R1 The next hop to reach 444 is 4.4.4.4, which makes sense because for R1, R4 is reachable, and when EBGP router, remember, when EBGP routers exchange their prefixes with other EBGP router, they put their next hop in here, means they change their next hop. Okay, so they have advertised it to the R1. So when R4 sent this update which you have configured on the R4 itself, and when it was received, so it has put its own next hop, okay, which was reachable. So that was the best reason, it was best. But when it exchanged with the R1 exchanged with R3, same as IBGP, so it doesn't change this next hop. All right, so 4.4.4 is not reachable from R3, obviously it is not. So it is not been made best by BGP. So what we need to do, somehow we need to change this next hop from forward.4.4.4 to what, the address of R1, like 1.1.1 or something. So for that we have one command in IBGP implementation, right? So that had something to do with that IBGP, what you can say, loop prevention mechanism and all, and that we discuss in some other route reflector and all those different concepts. But for now, let me show you how it is done. So you will go to your, so where I am, router BGP process, and neighbor is 3.3.3, and next hop is self. So this you need to change. Now that 4.4. part will be okay. R1 will say to R3, the next hop will be not that default one, but myself will be the next hop for you. So if R3 want to change, send anything to 4.4.0, use me as a next hop. So if you'll check here on R3 now, so the next hop will be changed, or maybe I need to run that do clear. You wait. BGP soft in, right? So after some time you should have that next hop changed, and now you can see this path has been made best. It will be put in the routing table and it will be exchanged with the neighbor router. Make sense? Now let's check it on the R5 then. Is it present there? Okay, show IP BGP summary. Has any prefix exchanged here? Okay, not now. Right, then show IP BGP. Nothing. So why is that happening? What are we missing? We have made the BGP neighborship possible, and on R4, let me check, do show IP route. So I don't have anything in the, let me just clear this, not recommended in production, but just because we are testing things. So let me just reset this TCP connection. The neighborship will be down for once, and it will be up again. Give it some time. I guess we had the message. Now if you'll check, do show IP BGP summary. Okay, R4 is not even receiving from though that side. Okay, it is receiving. Now do show IP BGP, not IP BGP, IP route. Static I have, but I don't have that BGP route. Why I don't have that? Okay, next hop is where I'm sorry guys, I'm making it, checking it on the R4. I should have checked it on the R5. My bad. Now show IP BGP, and that process I need to make on either R3 or R5. Remember that BGP neighborship part. Anyway, clear. IPBGP. Okay, let's see here on R4 show IPBGP. We have this 4 received from again I'm doing the same mistake. On R3 I need to check do show IPBGP, and that I have here do show IPBGP summary. Prefixes I'm receiving from there, and do show IP route. I should have that 4 route in my BGP table, right? And I should be exchanging it with R5 now. Let's try to check. Show IP BGP summary. Why I don't have that? Show IP BGP. Am I missing any command on R3? Do show run section BGP. So there I'm using 115 remote AS multi-hop update source loop back. So I guess on R3 towards R1 I'm not using that next hop self, but that will be used for exchanging that 5.5.50 prefix, right? Alright, update source is there. Then why I'm not? Let's do some troubleshooting. Do show IP route. This is present there. Okay. What about R5? Show IP route. I have a static route. I have my own route. Yeah. What are we missing here? And what we are missing here is, I guess, the next concept that we are going to discuss. And what is that? Remember one more thing here. So if I go here, right? Okay. So can I clear it? Just a second. If I can find the mouse. So if I just take a, you know, screenshot again, right? And I can just get it clean. All right. See what happens when your EBGP routers are exchanging routes, na? So what is happening? They are exchanging their AS number. So what is the AS number here? That will be 100. Okay. What is the AS number here? That will be 100. All right. And the EBGP neighborship or EBGP peers, when they exchange their prefixes or the update messages, they put the path attributes. So when we'll talk about in some different session, okay, the BGP messages and all, so there we'll see we have this update message, BGP update message, okay, and there we exchange the NLRI plus the path attributes. So that is nothing but fancy way to say, okay, this is my prefix that I want to share, and this attributes. So there are these 2-3 different type of attributes: mandatory or the optional, discretionary, transitive, non-transitive. So that's for later time or later session, but for now remember, when that's why basically it is called a policy protocol, because it has not metric, it don't has any best path selection algorithm. No, whatever you configure, so the output it will provide you, and by default there are some parameters it is using. So next hop is one of them, and your AS number is one of them, and things like that. So now when EBGP peers are exchanging the path attributes or the update messages, in those messages they are exchanging the path attributes. So one of the path attribute is AS number. Now this R1 received, okay, it is this message is coming from this 100, you can say, or it is exactly written like this. It is coming from a neighbor AS which is 100. Okay, now this is what your not EBGP, actually IBGP domain. And remember, by default in IBGP, one thing I have discussed, what, that it doesn't change the next hop. So for that, you remember I have used that command next hop self. And what else it doesn't change? It doesn't change the ASN. So it is receiving 100 and it is saying okay 100 here also. So what it could have done, it could have changed that from 100 to 200, but it is not doing that because that is not the behavior on for IBGP. So for that first part, I have used this command, but for here we don't have any command on R3 actually or R1. Okay, I don't need to do anything on IBGP side. I need to do something on the receiving side. And why, remember why this is a problem. Okay, so let's discuss that also, that not changing this is why not, why it is a problem. So we have discussed a little bit about the IBGP loop prevention mechanism, and in here we are discussing the EBGP loop prevention mechanism. See, when your receivers receives some update messages, and in that update messages it sees okay in path attributes there are AS number, and if it matches that okay from where it is coming, AS 100, and in which AS I am, AS 100, so it is thinking that okay it is a loop. So it will be like okay I'll be sending, I'll be receiving, I'll be sending, I will be receiving. So I don't want a loop. So whatever happens, I will not receive updates with the same AS number. So that's why it is rejecting that. So what is the remedy? What is the solution here? On R5, you need to allow that AS. So there is this allow AS in command. So let's try to run that. See if we are, able to have that prefix in R5. Or is there anything missing? Maybe a surprise for us. R5. I'll do router BGP 100 with neighbor 3.3 AS allow AS in. Okay, so let's see if we have to show IP BGP summary. Now you can see we are receiving a prefix, right? What is that? So that is 4.4.0. All right, so see here, now the path is originated from 100 coming from 200, and then the weight is 0 and all. The next hop is 3.3.3. Makes sense because that is your neighbors hop, because EBGP neighbors, they do change the next hop, right? All right, then what else? I want to have that 5.5.0 from R5 into the R4 also, which we should not be having right now. Show IP BGP only for show IP root, no 5. So let's do the same thing for R5 and advertise that 5.5.0, or maybe you could create a different loopback and advertise in the BGP, and you can keep 5.5 loopback for the neighborship only. So that is your choice. And the mask /24, right? And what else? That's it, I guess, for R5. To show IP BGP on R5, you will having that 5 best path with 000. It's your on, and for on the weight is this one, default value. And what else? This I will show you something, and then question mark, and then E. So that is one more session we can have, or a different topic, that root. So that will be basically coming under that BGP best path selection process. So again, we are not doing the same mistake. To check on R4, I'll do it on the R3. You have wasted enough time on that. Now show IP BGP summary. You should be having the prefixes from both sides. Fantastic. And now you should be having the prefix in your BGP table, 5 best path. So if it is in your routing table with the B keyword, okay, it should not be with the B because that is a R. Let me show you. Yeah, rib failure. Why? Because there is this root present in the routing table with the lower AD. So fantastic, no problem. It is in the routing table. It will be exchanged with your BGP, IBGP neighbor to be more precise. And show IP BGP summary. You should be receiving the prefix from both sides now, and 5 should be there in the this R1's BGP table, but it is not best. So that's why it will not be present in the routing table, and if it is not in the routing table, it will not be present in the site 1 side. So what to do for that? Remember the same allow AS. So the same thing is happening here. When R5 is sending the update, it is putting that 100 AS, sending to R3, putting that 100, no problem. It is 200. But when it is exchanging with R1, it is not changing the AS number, or you can say the 100 is there. So when 100 is received by R4, it means what? That I'm in the same AS, so I'm not going to accept that. So what you need to do? You need to allow this AS for this specific entry. Now what I will do, router BGP, it is 100 actually, neighbor, and neighbor will be 1.1 and allow AS, allow AS in. That's it. Now let me check, do show IP BGP summary. Okay, just wait for some time. Show IP BGP summary, clear IP BGP star soft in. So it is actually kind of generating a root refresh message so that it could have the refresh NLRI and your that update message. Why is it that R4 पे ही कर रहे हैं ना? हाँ, we are doing on the R4. Show IP BGP. Why we are not receiving on what are we missing in here? Show IP BGP 555. See here, next hop is not being changed. It means on R3 we are not running that command. See, that's what I told you, that there are so many things that we need to be careful about. Now router BGP, where we are at 200, neighbor 1.1.1, we are on R3, right? And next hop self, so that the next hop will be changed. Now let's see if it is being changed or on R1. Show IP BGP. It will take some time, or you can run that refresh command. So clear IP BGP. So you can see the next hop is changed now. And what on R4? What about R4? So you can see now, if you check the summary part, you should be receiving the update. And if you check the routing part, you are getting the 5 here. Now you have the prefixes, right? So it's like your client side should be able to access your server side and all. Let's try that. Ping 5.5.5, and if you'll do just like enter like that, so if everything is okay, still you'll not be able to ping or communicate. Why? Because I told you by default the exit interface or the source interface will be gig 0 by 0. And you have not advertised this 14 prefix 14.1.1.0 with R5. No, with R5 you have exchanged only what? The 4 prefix. So you need to mention, okay, from where you are making a communication, because see, your device clients will be in this 4.4.40 part, or that subnet, not in the 14 subnet, right? So I'm simulating, just simulating, but in real, your internal LAN users will be accessing your remote side. So remember that. So my source will be either, you can say 4.4.4.4 or loopback 0. But still it's not communicating. Why? Your packets are generating. Let me get in here, right? So if I can remove it a little bit. Okay, see, when you are sending the update messages from here to here, your EBGP pairs, right? So you have the information, okay, that to transfer that you can use this BGP pair, okay, and which will be sharing here. So fantastic, theoretically it makes sense, but when you need to transfer there, right? Connectivity is there, link layer you can say, or sorry, IP, network layer, transport layer, you have that. But what about the link layer connectivity? You need to transfer your packets through a link, right? From here to here. But does R2 have a clue about the destination? Because see, when you are sending the packet here, what will be the source IP? If you talk about the packet flow, source will be, sorry, destination will be 5.5.5 network. Source will be 4.4.4 network. Okay, you created this packet, transferred with R1. R1 shared it with R2, and when R2 will do its table lookup, so it will check, okay, the destination is 5.5.5.0. So do I know about 5.5.0? No, it has no idea about 5 because it will be having 1.1.1 information, 12 information, 23 information, 3.3.0 information by the IGP, the EIGRP protocol you are using, right? But not about this. So what you can do? Either you use IBGP neighborship on all the internal, we can say provider routers, whatever you have. Or I told you there is this MPLS concept you can use, MPLS technology you can use in the provider network, which makes your provider network core routers BGP free. Now, how is that possible? So when I'll say, okay, these interfaces here on R1, here on R2, and here on R3, when you will run MPLS, what will happen? So MPLS does what? We have shortage of time, I guess, and so let me go it through quickly. So MPLS will do what? MPLS will generate a label number, multi-protocol label switching. So label. So it is doing, it will do the forwarding based on labels, not the destination addresses, IP addresses, right? So it will say, okay, to reach to 5.5.5, it this R1 will say I'm using, let's say, 17 number. I don't know, 127 or 135 number. It will exchange with the neighbor router, let's say R2. And okay, whenever I'll share you this prefix 5.5.5.0, you don't need to do the layer 3 forwarding, the IP forwarding. No, just check this and see to forward this which next router you need to use, and there also MPLS will be running, and it will be saying, okay, to go to this, my number will be, let's say, 18, use 18. So without using layer 3 information, without doing that 32-bit searching process, it will just do the searching based on this 20-bit label. So which make it fast, because you can see from 32-bit destination extraction or 20-bit destination extraction, which one is faster, you can see. So MPLS is almost 60% more efficient than your normal traditional IP routing. So not getting much into that, let me show you how it is actually done, and is it done or not. So what I'll do on my core routers, service provider core routers, I will say, okay, on R1 interface gig 0 core side, right, and run MPLS. This is the command, a simple command to run MPLS. And what else? Now I'll say, okay, my interface gig 0 by 1 MPLS IP, MPLS IP. Similarly on R3 core side interface gig 0 by 2, I'll say MPLS IP, and you can see there is this protocol, as we have, routing protocol now for exchanging your layer 3 prefix information. We have this LDP, MPLS label distribution, tag distribution protocol, which is used to exchange the MPLS labels, MPLS label information. You can see the neighborship is up for MPLS, and there are many verification commands, show MPLS LDP binding is there, right? You can check that. Okay, as I told you, with every prefix, layer 3 prefix, it is generating a number. So even a neat command will be show MPLS forwarding table. So you can see local label, outgoing label. So there are things like rib and fib. RIB and FIB. In traditional routing, there are these, different type of switching available on the routers, process switching, fast switching, and then comes the CEF, Cisco Express Forwarding. So MPLS work on CEF. So the backbone of MPLS is basically CEF, that FIB, forwarding information base. So based on CEF, it makes this forwarding table. So if you disable CEF now, this will not be created and there will be no forwarding, no communication, nothing. So that's for some different MPLS class and all. But yeah, they will generate some local labels and will exchange with neighbor MPLS routers using the tag protocol, which is LDP by default. And the same will happen on every MPLS router. So the label of, let's say, R1 will create a label 10 for 1.1.0. It will share that with R2. So for R2, 10 will be the remote label to reach 1.1.0. So one router's local label will be like remote label for neighbor router. So not getting into that much detail, but what else we can say? You can see here POP label. So there are these three processes in MPLS that routers are adding the labels. They are what doing the pushing part or imposition of the labels. Routers in between, they are extracting labels, changing label. So those are doing what? Swapping the labels. And ultimate destinations, they will pop the labels, means remove the label, because to forward traffic from R3 to R5, no labels are there. You need to do the traditional routing again. So from R4 to R1 traditional routing, R1 to R2, R2 to R3 MPLS forwarding based on labels, and from R3 to R5 traditional forwarding based on IP routing or the layer 3 destination IP header. So that's it. So that's what about pop and push and imposition and swap and all. And you can see the same thing will be there. So there are these multiple things, in traditional routing you have rib and fib. In MPLS we have LIB, LFIB, lib and FIB fib and LFib, and there are these many things that we have in MPLS to discuss about. But the crux is, with every prefix you have a label, so your routers know without having layer 3 information. See this R2, show IP route, do show IP route. It doesn't have information about 5 route. See 4 route, no. But if you check show MPLS forwarding table, it has this information of MPLS, and based on that label, let's see what happens. If you try this now, see, magic, right? So that's where MPLS comes into picture in the providers network. So there are different concepts also. Let's say VRF with MPLS, VRF Lite without MPLS, how you virtualize the service providers routing tables, and you divide your global routing table into multiple virtual routing table based on different customers. You can have the same prefixes and can exchange the routes from different customers across provider network to different destinations without mixing them up. So that's where all the magic is about this MPLS and VRF and all those WAN and service provider technologies. I guess this was informative, and we had this great session. I enjoyed it a lot and hope the same on your side and you learned something new. And yeah, that's it for today's session, guys, and I'll see you maybe in some another one. Bye bye, take care.